welcome to our next video on measures of location. We're talking about something called a z-score. These are also called standardized scores. And we'll see why in a later unit. But most commonly they're called z-scores because statisticians, like everything in the universe, are lazy. Much like percentiles and quartiles, they give us an idea of where we are relative to the rest of the data set. However, they do it a little bit differently. Unlike percentiles and quartiles, z-scores are not going to divide the data into equal count chunks. The z-score is actually going to take our score and turn it into a distance from the center of the distribution. And it's going to do it with two values we haven't really talked about much yet, but the information is coming in a future video. So z-scores are measuring the distance from the center of the distribution. Come on, pens. And we're going to talk more about how we measure where the center is in a future video. And the formula for the z-score is, it is the data value that I want to find the z-score for, minus the mean, or the average of the distribution, divided by something called the standard deviation. And for now, we don't really need to know what those words mean as much as we need to know how to use them to calculate a z-score. And in a future video, we'll get some more details on what a mean and a standard deviation are. Before we do some calculations, these are used most often to make comparisons between data sets. So I'm going to give you an example. So I teach AP Statistics at the high school level, and this past year I had 3 sections. I had 87 kids taking AP Stats. And my second and third period classes had very different student populations in them. My second period was about a third juniors. It's a very young class. And it was my smallest section of AP Stats, and then my third period was my biggest class, and it had very few juniors in it. It was mostly seniors. So different performances, even though I was giving them the same test. So I want to compare Jackie from my second period class to Jose in my third period class. And on the test, Jackie got an 87%. Jose got a 73%. In Jackie's class, the mean was an 83%, and the standard deviation was 12%. In Jose's class, the mean was a 75%, and the standard deviation was 13.5%. And I want to compare how they did relative to the rest of their classes, and once I have those z-scores, then I can compare them to each other. So we're going to calculate a z-score for Jackie first. So z-score is the data value for the student minus the average on the test, the mean, divided by the standard deviation. So 87 minus 83 divided by 12. And we get 0.33. For Jose, we're going to do that same calculation based on his class's distribution of test scores. So Jose got a 73. The mean in his class was a 75. And his standard deviation was 13.5. So 73 minus 75 divided by 13.5. And we get negative 0.15. So what does that tell us? So let's do the comparison. First, this guy was positive, so the score was above the mean, above average, where Jose's score was negative because Jose scored below average on the test. And I can kind of see that looking at where they were relative to their class averages. Jackie was at an 87 with a mean of 83. Jose was at a 73 with a mean of 75. So Jackie was above the mean, Jose was below the mean. And I see that in the sign on the z-score. Positive z-scores are above the mean, negative z-scores are below. The other thing I can see that was less clear maybe in the picture is if I just look at that difference, that's a difference of 4 and that's a difference of 2. I think Jackie did twice as well. I can actually see based on her distribution and how spread out her data was versus how spread out his class was, 0.33 is actually a little bit more than double 0.15. That gap of 4 is more impressive because that range was less spread out about the mean. And so her bigger difference is even more impactful than a big difference in a distribution that is already really spread out. So z-scores give us a little bit more information about the spread of the data and allow us to make comparisons across different data sets for the same thing. These were both test scores in percentage form. All right, if you have any questions on the basics of z-scores, feel free to send me an email. Otherwise, I will see you in our next video.